Students, stay alert, stay alive. Here's the test review for test number 9, which is coming up at the end of the week. I'm going to whiz through these problems as fast and effectively as I can as to make the best use of my time and your time. So let's get started. Let's look at number 1. Remember, number 1, we see b cubed times b to the 5th. Alright, what I notice is that we are multiplying several exponentiated variables, b cubed, b to the 1st, and b 5th. So our rule says when we multiply powers, we keep the base, b is our base, and we add the exponents. 3 plus 1 plus 5 is 9. There's our answer. Alright, let's take a look at number 2. Okay, again, we are multiplying. So what we want to do is we will multiply our like variables with each other. So a squared times a to the 5th is a to the 7th. B to the 1st times b to the 4th is b to the 5th. All right, just Google exponent rules if your memory is hazy or if you don't have the notes readily available. And you will find that our power rule, our exponent rule, says when we multiply two variables that have the same base, for example, I'm looking at these a's are both a, they're both the same base, we keep the base and we add the exponents. 2 plus 5 is 7, 1 plus 4 is 5. All right? Let's keep going down here. Okay, number 3. For number 3, we need to call upon another exponent rule that we learned. What we just did in numbers 1 and 2 was power times a power. When you multiply powers, you add the exponents. Number 3, we see that we have several variables, an a and an x, that are exponentiated. It's an a cubed and an x squared. So there's the power, but the whole thing is raised to a power of 4. So this is what we call kind of the power to a power rule. So the rule goes, when we have a power to a power, we multiply them. So let's see what this looks like. 2 to the 4th power. That's the same as saying 2 times 2 times 2 times 2. 2 times 2 is 4, that 2 times 2 is 4, 4 times 4 is 16. So 2 to the 4th power is 16. A cubed to the 4th power is a to the 12th. We just called upon our power rule. A power to a power, you multiply them. You do not add them. Let's look at our x squared. X squared to the 4th is x to the 8th. Let's look at number 4. Okay, number 4, looks like we have two instances of our power rule. Here's one term, here's another term, so let's start over here. So, 3 cubed. 3 times 3 times 3 equals 27. So that's 27. A squared to the 3rd power is a to the 6th. We will add that to 2 times a to the 3rd to the 2nd is a to the 6th. Oh, Mr. Russell, why didn't you touch this 2? Why didn't you square this 2? I thought this should have been a 4. No. Why? Because look it over here. This 3 was inside of the parentheses. Therefore, this cube directly impacts this 3. Is this 2 inside of the parentheses? No, it's not. So, this square term has no impact on this 2. So we keep the 2 the same. Question, are these like terms? Oh, you don't know what like terms are. Like terms are when the variable is the same in each term, in this case a, and when the exponent is the same, in this case 6. So yes, these are like terms. So let's add these. 27a to the 6th plus 2a to the 6th is 29a to the 6th. Very good. Okay, let's come over to number 5. Okay, It's a multiplication problem, so we need to keep in mind that if we run into any exponents, we must add them. So first let's start with our scalars, with our numbers. Negative 26 times negative 0.5 is 13. A times A is A squared. Y cubed times y to the 7th is y to the 10th. We add them. Power times a power, you add them. We did not multiply them. There were no power to a power rules in here. Let's move along to number 6. Oh, okay. We have 11 to the negative 2nd power. You will recall that our power rule taught us, and we derived this rule in class. Our power rule taught us that if we have a, I'll write it near here, if we have a to the negative b, that actually equals 1 over a to the positive b. If we reciprocate an exponentiated variable, it changes the sign on the variable. And that's exactly what happened here. And this is how we can rewrite this expression using a positive exponent. This becomes 1 over 11 squared, which equals 1 over 11 times 11, which is 121. So the trick was realizing that we can take the reciprocal of this term, which is what we did right here. It changes the sign on the exponent, which is what happened. And then from there, we just simplify it. So this becomes 1 over 121. Okay, 7 and 8 look like they are coming up pretty quick here. Turn on my pen. Yes, pen, activate. Okay, we're doing some division. We're doing some division. Question, you remember that when we were multiplying two variables, we add the exponents. What do you think we do when we divide two variables? Yes, we subtract the exponents. So, let's see what that looks like. 6. Okay, so we'll rewrite that 6. I'll draw my line here. So 6 over, 1. There's just like a little 1 under there if you want to think of it that way. But I'm not going to worry about that. Now we need to take care of these r's. We need to discern how to take care of these r's. Well, isn't r to the cubed over r to the 7th, which is what we're looking at right now, isn't that equal to 3 r's on top and 7 r's on the bottom? 2, 3, 4, 5, 6, 7. Yeah, it is. And those will all cancel with each other. And that leaves us with 4 r's on the bottom. So you can think of it as, you could write this, that's fine, and that's the right answer. That's the right answer. But this is time consuming. This slows us down. So let me show you something else. So 6, so our rule says that we can, our rule tells us that we can take this 3 and subtract this 7 from it, and then that will give us r to the negative 4. So it looks something like this, 6r to the negative 4. Okay, but we're not done, because our directions told us to express all answers with positive exponents. Is this a positive exponent, this negative 4? No, it's not. So we express it, we use the rule that we just applied in number 6. So this becomes 6 over r to the 4th. Again, refer to your notes on exponent laws, exponent rules, if this is not making sense. This basically tells us r to the a over r to the b is equal to the r, we keep the base, and then we subtract the exponents. And if we get a negative exponent after we do the subtraction, then we must recall the rule which lets us move negative exponents to the bottom and thus change the sign. We reciprocate any variables that are exponentiated to a negative power. Let's take a look at number 8. Okay, 22 minus 11, I'm sorry, 22 divided by negative 11. We'll go term by term here. Well, we know 22 divided by negative 11 is negative 2. A squared divided by a, well, this is like